Throughout the history of science, individuals have sought to comprehend how the universe originated. The most prevalent explanation has been a concept known as the Big Bang theory. Numerous studies and the efforts of countless scientists endorsed this notion, providing evidence about how the universe commenced. However, in today's scientific landscape, new technology introduces fresh ideas and perspectives. These concepts challenge what we once believed to be indisputable truths. Neil deGrasse Tyson has emerged as a significant figure in this evolving scientific arena. Currently, something thrilling is unfolding with the James Webb Space Telescope, JWST. It's uncovering findings that may compel us to reconsider the Big Bang theory. The JWST has identified 750 new galaxies, differing from our expectations, prompting us to re-evaluate what we believed we understood about them. This telescope was designed to enhance our comprehension of how galaxies form, so it's not surprising that it's disrupting our grasp of the universe. Historically, scientists asserted that the Big Bang theory was the best explanation for how the universe began. According to this theory, approximately 14 billion years ago, the universe came into existence through a mysterious cosmic event, akin to the ultimate narrative of the universe's inception. Yet, the images from the JWST have questioned this notion. These visuals depict galaxies that are smaller, smoother, older, and more numerous than what the Big Bang theory anticipates. The theory also posits that as the universe expands, distant objects should appear larger the farther away they are, but these galaxies do not adhere to that principle. The theory further claims that, at the very dawn of the universe, all the matter that constitutes the cosmos was compressed into a minuscule, superdense point known as a singularity. This singularity was extraordinarily hot, hotter than anything we can measure or replicate. This concept of a singularity arises from a series of equations in physics proposed by Albert Einstein, called general relativity. Within the singularity, all the matter in the universe was crammed into a tiny space with extremely high density, meaning an immense amount of mass and energy was concentrated into a small area. In simpler terms, scientists have consistently stated that the Big Bang theory explains how the universe originated. But now, these new images from the JWST are prompting us to question that idea. The galaxies it has discovered do not align with the theory's predictions, and the theory's interpretation of the early universe may not be as definitive as we presumed. In our current perception of the universe, we believe that all energy began from a superhot and superdense point called a singularity. This singularity acts as the starting point for everything we observe in the universe today. Following this singularity, the universe began to expand and evolve over approximately 13.7 billion years to become what it is now. The expansion initiated with a process called cosmic inflation, where the universe grew at an astonishing rate, faster than the speed of light. It's as if the very fabric of space was stretching, pulling everything within it along. This cosmic inflation helped shape the universe by creating a more uniform environment and laying the groundwork for galaxies, stars, and other cosmic structures to form. As the universe continued to expand, it did not grow as rapidly as during cosmic inflation, but it kept increasing in size. We refer to this ongoing expansion as cosmic expansion. Scientists have observed evidence of this expansion through phenomena such as the alteration in the color of light from distant galaxies, known as redshift. Now, let's discuss those remarkable images of new galaxies captured by the James Webb Space Telescope. To most individuals, these pictures appear breathtaking, featuring hundreds of galaxies in a single frame. However, for scientists, it's somewhat unexpected. These visuals do not correspond with their theoretical predictions. Firstly, these galaxies are significantly older than anticipated, which challenges our previous understanding of how galaxies develop and evolve according to the Big Bang theory. Moreover, there are far more galaxies than we anticipated. The Big Bang theory made forecasts regarding the number of galaxies that should exist and their distribution, but the JWST images reveal many more galaxies than expected. This prompts scientists to question the accuracy of the theory's predictions. Some researchers are even beginning to feel anxious because these discoveries contradict their expectations entirely. Another astonishing feature of these new galaxies is their smoothness, which contradicts the implications of the Big Bang theory. According to the theory, galaxies should display irregularities and variations in their structures based on how they formed and developed. However, the images from the JWST reveal galaxies that are unusually smooth, lacking the anticipated complexity and roughness. During the universe's expansion, everything that constitutes our universe was compacted into a very small area. As the universe expanded and cooled, changes occurred in particles like protons, neutrons, and electrons, which began to interact with light and energy around them. These interactions were crucial in shaping the formation of matter in the universe. In the initial moments following the Big Bang, a process called nucleosynthesis occurred, involving the creation of lightweight elements such as hydrogen and helium. These elements established the groundwork for the formation of stars, galaxies, and more complex elements as cosmic history unfolded. This synthesis of fundamental building blocks was a significant step in the evolution of the universe, transitioning from a primordial mix of particles and energy to a state where matter began to take form. The Big Bang theory anticipated observing galaxies that were disordered and disrupted due to numerous collisions. However, the JWST images present a different narrative. Instead of chaotic and irregular galaxies, the pictures display smooth disks and well-organized spiral shapes that resemble the galaxies seen in the present-day universe. This unexpected observation challenges the notion that mergers are a frequent component of galaxy evolution. If there are very few or no mergers occurring in these galaxies, as suggested by the Big Bang theory, it becomes improbable that small galaxies could grow to become hundreds of times larger. Moreover, the visual illusion expected from the expanding universe theory, where objects seem smaller with increasing distance due to expansion, does not appear to be evident. Astronomers have noticed a remarkable trend where galaxies tend to group together in substantial clusters, forming complex networks throughout the cosmos. This observed large-scale configuration aligns with the forecasts made by the Big Bang theory. According to the theory, the universe commenced in an extremely hot and dense condition and then gradually expanded and cooled over time. As the universe enlarged, gravity played a crucial role in determining how matter was distributed and in orienting galaxies. The gravitational influences anticipated by the Big Bang theory are consistent with our present observations, with gravity pulling matter together, leading to the clustering of galaxies and the creation of interconnected filamentous structures known as the cosmic web. The existence of these galaxy clusters and the cosmic web arrangement strongly bolsters the Big Bang theory. The spread of galaxies throughout the universe corresponds with the gravitational effects predicted from the initial dense and expanding state proposed by the theory. All of these components, including the grouping of galaxies, the cosmic web structure, and the arrangement of galaxy clusters, provide solid evidence that the universe evolved from an extremely dense state and has been expanding for billions of years. Now, let's reconsider the dimensions of the galaxies discovered by the JWST. These images challenge our earlier understanding of the Big Bang theory. According to the theory, smaller galaxies should develop and enlarge through collisions and mergers with other galaxies. However, observations made by the JWST have raised doubts about this idea. If galaxies were colliding and merging as expected, we would see evidence of these interactions in the galaxies involved, but the images present a different scenario. So, is the Big Bang theory simply a notion lacking evidence? No, it is indeed supported by compelling data, including observations of the redshift of light. Evidence from distant galaxies supports the expanding universe theory. Observations showing galaxies receding from one another in all directions imply ongoing expansion as predicted by the theory. The abundance of light elements like hydrogen and helium found throughout the universe also aligns with predictions of the Big Bang theory. Furthermore, the large-scale distribution of galaxies revealed through astronomical surveys matches the patterns forecasted by the Big Bang theory. One of the most significant pieces of evidence for the Big Bang theory is the discovery of the cosmic microwave background, CMB. The CMB is a faint radiation that permeates the entire universe and represents the afterglow of the Big Bang. This cosmic radiation, first detected in 1965, closely aligns with the predictions made by the Big Bang theory. The observed characteristics of the CMB, including its uniformity and temperature distribution, strongly support the notion that the universe was once in an extremely hot and dense condition before undergoing expansion, a central element of the Big Bang theory. The discovery of the cosmic microwave background is a vital piece of evidence that provides a unique glimpse into the early moments of the universe. It serves as an echo of the initial stages following the Big Bang and has played a crucial role in solidifying the Big Bang theory as our best explanation for the origins of the cosmos. However, recent findings have questioned certain aspects of the Big Bang theory. The existence of galaxies with ages that seem to predate the Big Bang contradicts the fundamental premise of the theory, suggesting that the Big Bang may not have occurred as initially believed and that everything may not have originated from it. Proponents of the Big Bang theory had expected that as the JWST observed further into space and deeper back in time, the number of observable galaxies would decrease, potentially leading to a cosmic dark age. However, recent research indicates that even a few 100 million years after the hypothetical Big Bang, galaxies as massive as our Milky Way were common. The JWST images reveal a much greater abundance of large galaxies at redshifts greater than 10 than theorists had predicted, challenging the plausibility of the Big Bang theory. Additionally, the Big Bang theory is linked to 16 incorrect predictions in the current body of scientific literature, with only one accurate prediction regarding the abundance of deuterium, a form of hydrogen. Some of these erroneous predictions include estimates of helium abundance, which are off by a factor of 2, and predictions for the abundance of lithium, which are off by a factor of 20. In summary, it's evident that Neil deGrasse Tyson, a leading expert on space exploration and cosmology, views the developments surrounding the James Webb Space Telescope as groundbreaking and highly significant. The telescope has uncovered new galaxies, which, contrary to our expectations, challenge the Big Bang theory. This has sparked a new era of scientific discovery that could reshape our understanding of how the universe originated and evolved. Consequently, the JWST's revelations have prompted scientists to rethink and re-examine the Big Bang theory, suggesting that it may no longer hold up as the ultimate explanation for the universe's beginning.